Hey folks, so today we're going to be talking about two-dimensional motion in a different way. So basically, the next part of 2D motion is what we call projectile motion. We're going to start with a special case called horizontal projectile motion, where we're just starting out, just moving horizontally. So when we talk about a projectile is any object that's going to be moving above the Earth's surface with only the force of gravity acting on it. So things that would be projectiles would be things like a ball, or if I fire a cannon, the cannonball would be a projectile. A kangaroo would be a projectile. Once the kangaroo's up off the ground, its feet aren't pushing on the ground again, only gravity's pulling it back down. Things that wouldn't be projectiles would be things like planes, birds, rockets. So a rocket is exerting a force, keeping it up above the ground. And if you're in a plane has wings. Those wings exert a force, keeping it up off the ground. So if you're in a plane and it becomes a projectile, it's a bad day. Coming over here, I just want to give you a reminder about free fall motion. So when we talk about free fall motion was any object moving vertically above the Earth's surface. So we talked about how basically any mass, if I drop it, is going to be in free fall. And then I'm bringing back the free fall equation. So we got our how fast formula here, our how far formula down here. So free fall and projectile motion are kind of similar, right? So, we've got basically the projectiles moving. Free fall, we're moving vertically. So free fall motion is kind of like a special case of projectile motion. So real quick, and I promise I will prove this to you when we get to class. But hey, which would land first? A ball fired horizontally or a ball dropped from the same height? Or would they land at the same time? Take a second, answer now. Welcome back. So here's what's up. If we think about this, we've got our ball fired horizontally and our ball dropped from the same height. Both of these are going to be accelerating down due to the force of gravity at the same rate. G's the same on all objects. Now, if we take a look at this, a split second later, they'll both have fallen some distance. This one's going to fall the same distance, but it's going to move over a little bit. An equal split second later, it's going to fall down some more. This one's going to move the same distance and fall down some more. When we get to the ground level, boop, boop, we would find that it has taken this arced path. So projectiles move in. So this arc here, proper term for it, this is only half of one, but it is a parabola. So when we talk about the trajectory of a projectile is its path, and all projectiles are going to move in parabolas. Now, just in case you're like, I don't believe that at all. So here's what's up. If we think about relative motion, right? If we pictured somebody and they're riding on a flatbed train car and they're holding something that they're gonna drop, I don't know. So they're moving on a flatbed train car at a certain velocity. If you're standing, oh my goodness, you're huge compared to them. Either they're short or you're gonna make it in the NBA. So if you're watching them drop this ball, right, from their point of view, they would be like, it's free fall. Because to them, they drop the ball and it's gonna land right next to them. In their point of view, it just moves straight down. From your point of view though, as the car is moving, the path of the ball is gonna make that parabolic shape. And you're gonna say, it's a projectile. Now, the reason why I'm bringing this up is while you can't agree on the path, you can agree on when it lands. So if you work out our free fall equation, right? So we talked about our free fall equation. In this case, we're dropping it. So that part's just gonna go away to 0. And then we're solving for time. So YF is also gonna be 0 because we're landing on the ground. So we would do negative Y naught is equal to 1/2 G delta T squared. And then to get that delta T by itself, we would end up with the radical -2 Y naught over G. You might have solved your algebra a little bit differently. 6 of 1/2 dozen the other if you've got a 1/2 G down here at the bottom. Anyways, if we plug this in for the numbers that we get, so -2, just having some fun, doing some physics in the dining room. Please don't judge my carpet. It's a little dirty. So when we work all that out, you should find that it lands in 0.25 seconds. So coming back over here, both you and the person on the train cart are gonna agree that it lands at 0.25 seconds. So basically, you're both gonna agree when it lands. So since this is true, this also has to be true. And I get it. 17-year-old me would have been like, nah, that one lands second. But here's the thing. Most of the time people think about that, they think about a bullet being fired. Well, bullets aren't in the air for very long. They fall down just like everything else. As soon as they're out, they start accelerating down and they do fall. They do go, they're projectiles, they're gonna be in free fall. Now, since we've got a new type of motion, we're gonna wanna take a look at our projectile equations. Now these projectile equations, we've seen them before. I'm just putting a new coat of paint on them, right? This is me putting a spoiler on the Hyundai Accent instead of like making a nicer car. So when we're talking about the horizontal, well, acceleration in the horizontal direction for a projectile, the only force acting is gravity. So what that means is there's nothing making it accelerate in that horizontal direction. It's not speeding up or slowing down. So we're gonna get 0 meters per second squared there. Okay. Sorry, my marker's seen better days. In the vertical direction, we're gonna use G, just like before. And then I have said that like free fall motions on Earth, I've said projectile motions on Earth. If you go to Mars and you throw a ball, I'm really proud of you, but that ball would still be a projectile. Like when I say Earth, that's because I've got an Earth-centric viewpoint, and I'm working on that. When we talk about how fast, my how fast equation horizontally, I know you're like writing this down as I'm doing it. Hold off on this for just a second. My final X velocity, so I'm adding an X here just to talk about going horizontally. V final X is going to be equal to my initial X velocity. So like I said yesterday, my x direction and my y direction, they're not related to each other. So I can move in the x without moving in the y. And then this is going to be plus ax times delta t, which is great. It's my old how fast formula, except here's the thing, that's 0. So I'm left with this. Vf equals v naught x. So the final x velocity is equal to the initial x velocity. So the horizontal motion is constant, which is really helpful for us actually. When we talk about how fast vertically, well, now we've got Vfy, which is equal to v naught y plus g times delta t. You know what? This is our how fast free fall formula. So this is free fall motion. All we've done is we've added a y here to separate that we're going vertically instead of just moving at all like we were back in unit 2. For my how far formula, the same thing's going to happen. I have no acceleration, so as I'm writing where my final position is, that's going to be equal to where I start out. Usually we'll do 0 for that, plus v naught x times delta t. And I can forget about that acceleration term because acceleration is 0. So I've just got that. Now on the test, you are going to get the regular how far formula, and you're going to have to remember, oh, it's a projectile. Acceleration in the x direction is equal to 0. For vertical, we've got y final is equal to y naught plus v naught y delta t plus 1/2 g delta t squared. Now, in this situation that we have horizontal projectile motion, so if we're saying horizontal, that means initially we're just moving horizontally. So when you hear that, that means v naught y is going to be 0 meters per second initially. Now, as soon as that projectile leaves whatever's projecting it, it is going to start to accelerate downward, so that v naught y is not going to stay 0. If it did, then it would just like float above the ground. So there we go. That's my notes for today. See you tomorrow.